Assalamu alaikum students. So here I am with another new topic of organic chemistry, that is nomenclature. If you are really interested in learning nomenclature of organic compounds, or you want to learn other topics of organic compounds, then organic chemistry, then kindly subscribe my channel and click the bell icon. And you can also comment below for the discussion of anything. So let's start today's topic. And in this series I am going to teach you, or I am going to discuss many topics. These are basic concepts of nomenclature: nomenclature of alkane, alkenes, alkynes, halogens, nomenclature of alcohols, nomenclature of aldehydes, nomenclature of ketones, acids, ester, amines, and nomenclature of cyclic compounds, and the nomenclature of bicyclic compound. So you are going to learn many things in this series. So watch the series and learn a lot of things. Before you start watching this video, I will recommend you to watch previous two videos as well. Okay, this is the seventh point, which is when two or more substituents are identical, means same. Indicate this by the use of the prefixes di, tri, tetra. Right? If there are two methyl groups present in the compound, so we will use di. If there are three, we will use tri. If there are four, we will use tetra, and so on. So there is a compound, right? So first step is to count the number of carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 9. So there are 9 carbon in the molecule. There are nine carbon in this structure, and you can see here there are two branched, right? There are two substituents. Both are methyl, right? Both are same or identical substituents, right? So we should start counting from here. So this is the third number, and this is the sixth number, right? So the 3, how we will call it? 3,6 dimethyl, right? 3,6 dimethyl nonane, right? So its name would be 3,6 di. Why di? Because there are two methyl groups, so dimethyl nonane, right? It is very simple. Then move to this example. First step is to count the number of carbons. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 carbon in parent chain. So 8 means octane, and you can see here 1, 2, 3. So there are 3 substituents attached to the. There are 3 same substituents attached to this parent chain. So what will be its name? 3, 4, 6 trimethyl octane, right? So its name would be 3, 4, 6 trimethyl. Why? Because there are 3 substituents, 3 methyl groups are attached to it. So 3, 4, 6 trimethyl octane. So the 8th point is when two chains of equal length compete for selection as a parent chain, choose a chain with a greater number of substituents. So हमें क्या करना है? We have to select the chain which have greater number of substituents. So we can select this one, right? So there are how many carbons? 1, 2, 3, 4, 5 and 6, right? Or the other possibility is this one: 1, 2, 3, 4, 5, 6. So which chain should be selected? So we will select this chain, right? This one. We will select this chain. Why? Because it has greater number of substituents are present. So what will be its name? There is methyl group at the second position, right, and the methyl group at the fifth position. So the 2,5-dimethyl, and at the third position it is propyl. So 2,5-dimethyl 3-propyl hexane, right? This is another example. So you can see here, this one is chain, right, or this one could be chain. So which chain we will select? We will select this one, right? So we will select this chain because there are more substituents in this chain, right? So the name would be 3-ethyl, right? 3-ethyl 2,5-dimethyl hexane. The ninth point is, when branching first occurs at an equal distance from either end of the longest chain, choose a name that gives a lower number at the first point of difference. So in the example you can see here, right, methyl occupies second position from here, and similarly methyl occupies second position from here, right? But from where we will start giving number, or from where we will start locating. So we will start it from here because it's giving the second number to it and the third number to this one, right? But when we will start it from here, so it will get fourth number, right? So we will start the number from that side, from where we can get the more substituent nearer to the nearer, right? So the name would be basically 2, right, 2,5-dimethyl. Sorry, there is little bit, this is down, right? So 2,5-dimethyl 3-propyl hexane, right? In this example, here you can see here, the first work is to select the longest chain. The second thing is 1, 2, 3, 4, 5, 6. So it is going to be the same or not? No, not. It's going not. So you can see here 1 methyl is here, 2 is here. So we will start number from here, right? 1, 2, 3, 4, 5, and 6. So what will be its name? Its name would be 3-ethyl 2,5-dimethyl hexane. Let's summarize basic steps of IUPAC nomenclature of organic compounds. The first is to locate the longest continuous chain of carbon atom. This chain determines the parent name for the alkane. So the first step is to determine the longest chain, right? So what is second point? The second point is the number the longest chain beginning with the end of the chain near the substituent. So if the substituent is attached to here, so we will start numbering from here, right? 1, 2, 3, 4, like that. The third is use the numbers obtained by application of rule 2 to designate the location of the substituent. So I will use this number to locate the position of the substituent. So in this molecule you can see here substituent is attached to the second position, right? The fourth point is when two or more substituents are present, give each substituent a number corresponding to its location on the longest chain, right? If there are more substituents, right? Let's attach the substituent here, right? This is ethyl group I have attached. So what we will do, we have to locate the number according to their positions. The fifth point is when two substituents are present on the same carbon atom, use that number twice, right? Let's suppose at this position one ethyl group is also present, so we will use this number twice, right? 2 methyl, 2 ethyl, 2 ethyl, 2 ethyl, like that, right? So the sixth is when two or more substituents are identical, indicate this by the use of the prefixes di and tri. So you can see here at the second position there is a ethyl group, right? And at the fourth position there is ethyls also. So we will name it like 2-ethyl 2,4-diethyl. So we will name it like 2,4-diethyl, right? Then when two chains of equal length compete for selection as the parent chain, choose a chain with the greater number of substituents, right? So if there are two chains which are competing each other for parent chain, so we will select the chain with less number of with a greater number of substituents. So for the example, you can see here 1, 2, 3, 4, right? 5, 6, 7 and 8. There are 8 carbons and we can also count 1, 2, 3, 4, 5, 6, 7 and 8. So two chains are competing each other for the selection as a parent chain. So we will select this chain. Why? Because it have more substituents, right? So if there are more substituents, so we will select that chain. And the last point is when branching first occur at an equal distance from either end of the longest chain, choose a name that gives the lower number at the first point of difference. So let's try to. So you can see here here 1, 2, 3, 4, 5. So there are 5 carbons. So no, 6 carbon, right? So you can see here that the methyl group is present at the second position from here and at the seventh position from here. So from where we should start counting? We will start counting from here because 1, 2, 3. So it will give the third position to this methyl group as well. If I start counting from here, so you can see here it will give 1, 2, 3 and 4. So 4 positions. So I will locate the number from this side to get the near substituent.